During our test, we created a flood that showed how sediment was redistributed. We took 3 flasks of water, and once the river was filled, we gently poured each flask of water into the beaker at the end, one at a time.
During test 1, it overwhelmed the river boundaries and extremely widened the banks. It almost made another channel. During test 2, the same thing happened, and it appears that the meander was different and allowed it to carry more sediment. Also, the plain flooded more. During test 3, towards the end of it, had a huge change due to the angle of the flood eroded the side of the riverbank, causing it to flood.
During the flood, the width of the river also increased, so obviously that means sediment was being redistributed. The depth of the river increased also, all but one test. If you look at the graphs, you can tell that when the width increased, the depth decreased a little bit. During a future flooding event, I believe that water would flow along the land. Then, as time passes, it would retract back into the river, bringing more sediment and materials in. Also, based on our data, the river would become deeper and wider most of the time.
In test 1, the black sediment is sprinkled all over, which makes me think that this test was inaccurate. In the second test, the black sediment is concentrated on the top layer of the riverbed, and it is concentrated in one mass in the center that goes all the way to the bottom of the riverbed. In test 3, the same thing happened. There is a thin layer of the black sediment on the top layer of the riverbed, then it is less concentrated below that level. Finally, in test 4, it is basically the same situation as test 2 and 3, but in this test, the black sediment is also clumped onto the sides of the riverbed.
Sediment is redistributed during a flood by the water speed picking up whenever we poured the water into the beaker. When the water speed picked up, it carried sediment with it and created a meander. When the water flooded the river and created the meander, it carried sediment out.
The relationship between the width of the river before and after the flood was y equals 1.141x plus 2.425. The relationship between the depth of a river before and after the flood was y equals 0.307x plus 1.207. You could use these equations to predict accurately how deep and wide a river will be after future floods.